Hello, geometry students. All right, coordinate proofs with arbitrary coordinates. So on this, we've got some arbitrary coordinates. We've got a is 0, 0, b is 0 plus some number x. We don't know what it is. C is the coordinates a plus x. Again, we don't know what a is. We don't know what x is. And then comma b. So we don't know how high it up it is either. You don't know the b coordinate. Here's x. And then we've got here a comma 0. A plus x is right here. So we don't know where these coordinates are. Can we still prove the triangles are congruent? And the answer is yes. Yes, we can. So I'm going to show you lots of different ways we can get the information we need. The first way, well, we get some things right off the bat. We get the vertical angles right here. So by vertical angles, angle BXA is congruent to angle CXD. So that's one we get for free. That's very, very nice. We like that. Next, what we could do is we could find the length of each side. We could do that. So let's find the length of AB. All right, to do that, we're going to have to use the distance formula. So we're going to do x1 minus x2 squared, 0 plus x minus 0 squared, y1 minus y2 squared, so b minus 0. And once we simplify this, we're going to get just x squared plus b squared. No, it is not. If you take the square root of this, it is not just x plus b. That's not true. So the answer is just square root of x squared plus b squared. We're going to do the same thing for CD. So for CD, I'm going to do x1 minus x2, a plus x minus a squared, plus y1 minus y2, b minus 0 squared. So after we do some simplifying, x plus a minus a is just going to be x squared, b minus 0 is just b squared, and we get x squared plus b squared. Hey, those are the same thing. So AB is congruent to CD. And we have to show how we got both those numbers. It's great, so I can mark those congruent. I could do the same thing for BX and XD, and then AX and XC. I'm going to take a different approach though. I'm going to find some other sides that are congruent. I'm going to do that using the midpoint formula. So the question is X the midpoint of BD? Well, I'm going to do something here. Midpoint of BD is, so let's see here. Midpoint formula is add the x's and divide by 2. So I'm going to take 0 plus x plus a and divide by 2. I'm going to add the y's and divide by 2. And that's going to get me, well, just I'm going to rearrange it, a plus x over 2 and b over 2. But that is equal to the point x right here, the coordinates for x. So x is the midpoint of BD, which means BX is congruent to XD. All right, so That gets me these sides are congruent. Unfortunately, Mr. Kuhn, that's angle side side. And Mr. Kuhn kills puppies if we try to use angle side side because that does not work. So we need something else. I could do the same thing right here. But of course, Mr. Kuhn's not going to do that because I'm going to show you another way we can prove angles are congruent. For this one, it looks like these sides are parallel. So let's actually see if the sides are parallel. So I'm going to find the slope of AB. The slope of AB is, so subtract the y coordinates, y2 minus y1, b minus 0 over x2 minus x1, 0 plus x minus 0. And that's just going to get me a slope of b over x. The slope of CD. So again, I'm going to subtract the y coordinates. Y coordinates first. B minus 0 over, subtracting the x coordinates, a plus x minus a. And that's going to get me, well, those a's go away, it's going to get me b over x. Well, that's great. So the slope of AB is equal to the slope of CD. So AB is parallel to CD, which means angle B is congruent to angle D because they're alternate interior. Well, this is fantastic, Mr. Kuhn. Now we really have our choice. How do we want to do this? Do I want to, we could do angle, side, angle. We could do side, angle, side. We could do angle, angle, side. So depending on which ones you actually used, that's going to determine everything. I'm going to use the, I used this to prove those sides are congruent. And then, so there's a side, there's an angle. So I'm also going to use this down here. So all three of these things allow me to prove triangle ABX is congruent to triangle CDX by angle, angle, side. So there you go. The big thing we need to take away here is don't freak out because you don't have numbers. Don't freak out because you don't have numbers. It's okay. We can still do everything we need to do. These have the same slope. It doesn't matter where B is or where X is because it'll have the same slope as this one. It doesn't matter where B and X are because no matter what I plug in, if I plugged in 2 and 5, 2 squared plus 5 squared is going to equal 2 squared plus 5 squared. So there you go, ladies and gentlemen. Coordinate proof with arbitrary coordinates. Thanks so much for watching.